Our solar system is unlike any other discovered in the cosmos to date, and a rogue baby Jupiter might be the reason why it's so weird, and even home to life. The solar system consists of 4 inner planets: Mercury, Venus, Earth, and Mars. They're known as terrestrial planets because they're made up of mostly heavy metals like iron and nickel. In comparison to other planetary bodies, they're pretty small, and their atmospheres are thin. Meanwhile, the gas giants in our outer solar system, Jupiter, Saturn, Uranus, and Neptune, are much larger. And unlike other observed gas giants in the cosmos, they're really far from their parent star, our Sun. So why exactly is our solar system so diverse and spread out over billions of kilometers? For centuries, our solar system was the only model we had to learn from. But thanks to NASA planet hunters like the Kepler Space Telescope, that all changed. We've discovered more than 3,000 exoplanets orbiting other stars, and a portion of them reside in multiplanetary systems. So far, scientists have found that the typical multiplanetary system consists of a few super-Earths, extrasolar planets with masses larger than our own planet, but less than the gas giants. They tend to be similar in size, with evenly spaced out orbits, and are located closer to their stars than Mercury is to the Sun. We really can't say for sure why our solar system is so different than others, but some scientists point to our largest planet as a possible explanation. One theory takes us back to the formation of the solar system billions of years ago. It claims that the Sun was once surrounded by first-generation inner planets on their way to becoming super-Earths. As the planets were forming, it's believed that young Jupiter began migrating inward in a scenario known as the Grand Tack. It claims that as Jupiter moved towards the Sun, its gravitational perturbations caused the planet's orbits to overlap, resulting in catastrophic collisions. Some of the premature planet pieces were sent spiraling into the Sun, while others remained floating in space. Jupiter was allegedly pulled back towards its current location when Saturn began to form, allowing for the remnants of its havoc to form into a second generation of planets, or the inner solar system as we know it today. If true, the Grand Tack scenario helps explain why the terrestrial planets are much smaller than typical super-Earths. Some scientists believe Jupiter's messy migration could also explain how liquid made it to Earth. As the gas giant wandered back out into space, its gravitational pull latched onto asteroids that formed beyond the snow line, which is the distance from a star where icy compounds can condense. Jupiter flung icy space rocks inwards to the asteroid belt and the region where Earth was forming. It's believed that these icy asteroids would have delivered enough ice to account for Earth's oceans, essentially providing us with the building blocks for life. So the Grand Tack claims that if juvenile Jupiter hadn't swung through our early solar system like a wrecking ball, Earth would never have been created, and we wouldn't be alive today. It's clear there's still a lot we need to learn about our alleged cosmic creator because, after all, these scenarios are still theories, but they do help answer many of the growing questions about the oddity of our solar system. And if they hold truth, as some scientists believe, we have a lot to thank Jupiter for. Spacecrafts takes you through the depths of the cosmos, explaining bizarre astronomical phenomena and crazy plans for future exploration. Check out other episodes like this one, about humanity's first ever trip to a star. Be sure to follow this page, and don't forget to share with your friends.